Hi, Tarun. We'll start in a few minutes, right? Once we have enough students, I'll just wait for a couple of minutes more, see if more students join in, and then we will start. All right? Okay. All right. I think we're good to go. Am I audible now? Is my voice audible? All right. Perfect. Um, So today, I think today is the seventh class on the strings micro course, and today we are going to be covering KMP algorithm, right? We've already covered a lot of string algorithms, right? We also saw a few problems around that as well. Everything will remain same for this class as well. I'll give a quick intro again about naive pattern matching algorithm. We'll also discuss a few disadvantages, right? The one we have already talked about as well. We'll talk about a few disadvantages with naive, and we'll see how KMP algorithm is good for us and how KMP algorithm solves that problem. We'll also talk about what inherently KMP algorithm uses. It uses an suffix function kind of an array. That is in here the suffix function is the longest prefix suffix, right? We'll talk about what longest prefix suffix is, and that exactly forms the whole backbone for the KMP algorithm, right? So we'll understand both the concepts. What exactly is that longest prefix suffix function, right? How is it used for KMP algorithms, and what are the different areas where this particular function can be used for what different problem solvings, right? We'll also implement it, right? We'll take up a few corner cases as well, right? We'll take up a few cases in which this algorithm is actually can be like used for pattern searching, right? I'll take a few examples to work around them, and then we will implement this whole functionality on an IDE, right? So that will be the whole agenda for the class today, and this is how we will proceed, right? If there's any doubt at any point that you feel there's something that you want to clarify, something that you want me to repeat, please feel free to ask that, right? I'll take up any doubts that you have. Okay, perfect. Just give me a minute. I'll just quickly see if the settings are right. All right, perfect. So we'll start with KMP algorithm, right? Now, before talking about KMP algorithm, we'll see what exactly is a naive pattern matching, right? So basically, you are given a text, right? This text is in a form of a string, and you are given a pattern as well, right? And the idea is to find all the occurrences of this pattern in the text, right? So usually the size of the text is very greater or very big compared to the size of the pattern that we are looking for. So let's say the text is A B C Y X D A C. Let's say the pattern is CDYXT, right? So this is the pattern, and you want to check if this pattern exists in this text or not, right? So what would ideally be done here is, let's say this is the text ABC. Let's say AB. I'll change the text a little bit. So this is my text, and this is my pattern, right? So I have to find the pattern, and the pattern is CD by XT. So what I will first do it, I will try to see if that pattern is here, right? So I will match A and C. Since they do not match, so I will simply move forward. Now I will try to see if I can find a match here, right? Again, I see that the first character itself does not match, so I move forward, right? This is how I am basically moving the pattern at each step. So now here this C and C matches, but this C and A does not match, right? That means this pattern cannot exist here. So what we will do next is we'll again shift this pattern, and we keep on shifting it. Let's say I shift it to here. I've reached to this iteration, right? Now what exactly will happen here is, first I will match this and this. They do match. Since they do match, then I only match the second character. So I match this. Now I will see that these characters do not match, so I simply move forward here, right? So what you are seeing here is, after doing three comparison, on the third comparison I find out I had do not have a match, right? And what I had to do here is, I had to start exactly again from this position, correct? And here again I started matching D and C, and they did not match, right? Now again I move forward in this direction. Let's say I have reached here, right? Now what will happen is, I will match this and this. They match. Then I will match this. Again they match, again they match, and again they match. Since I have matched all of them and we reached here, and we have traversed to the entire pattern dot length, in that point we can see that this pattern exists, right? So that is what the overall idea is here, right? Now, similarly, we keep on moving. So a problem that we saw with this approach was that after doing, let's say, all these comparisons, right? In this example, after comparing CD, the third character of Y and X did not match, but we could not use any information at this point, and we had to start traversing the string again, right? And a worst case could have occurred here, when the text would have looked like this and the pattern was this, correct? So now you will match this and this, you will match this, they both match, you match this, and on the last character you will see that there is not a match, right? So now what you will have to do is, now you will have to start all over again, and you will have to start this, right? And again also you will match this and this, this and this and this, and this will not match. So you will see here that the overall complexity becomes m into n, where m is the length of the pattern, I say, and n is the length of the text. Now for normal cases this might work and we have no issues as well, but you will see that for very large text and very large pattern, this complexity actually increases a lot, and definitely not a good way to solve this problem, right? So this was naive pattern matching, right? This was naive pattern matching, and definitely not a good way to go about it, right? And definitely not a good way to solve the problem. Now, what we'll see is, we'll look at a more optimized approach of how we can actually solve this problem, right? So what we will do here is, we will see that we have a pattern, right? Okay. Um, Now here, what we will do is, we will calculate the prefix function for this, I can say, particular string, right? For the given pattern, right? Now how we solve here is, for the given pattern we will calculate its suffix function, right? Now what happens in this suffix function is, I'll explain that. You have a string of length n, right? And the prefix function, right? What is this? Sorry, this is prefix, I'm sorry. right? Now, what exactly happens is the prefix function for the string, for any given string, is defined as an array, right? Let's say we call that array pi, that is of length n, right? Where at any index of this array is the length of proper prefix, right, of the substring. Now this definition is very important, of the substring s to I, which is also a prefix of the substring 0 to I, right? Now, when I say proper prefix, right, here I have used the term proper prefix, right? So what exactly do I mean by proper prefix is a proper prefix of a string is a prefix that is not equal to the string itself, right? So what exactly does that mean is, let's say I have a string a b c a d a b c, right? So if I first have to just find the prefixes of this string, those prefixes are those substrings, right, which starts from the left point, right, which starts from the left end. So with these things, the prefixes are a b, a b c, a b c a, and A, B, C, D, A, B, D, right? These are a few prefixes, A, B, C. No, this is A, D. This is A, D, A, B, A, B, C, A, D, A, B. Similarly, you can go on, right? Now, we also have the concept of suffix here. Now, what exactly is a suffix? Now, a suffix is a substring, but the end of that substring will always be the right end. Correct. Dharan, yes, that is the information, or that is the core idea here, that we are doing some iterations, right? And now, since we did compare these two characters and the third one did not match, we are actually not using this information of these first two characters that is matched, which could have also helped us to save a few iterations, right? So that is the whole idea here, that to use that some information to save a few iterations here, and in the end to reduce the overall complexity as well. All right, I'll not be able to see your questions or any doubts that you post frequently, but I'll try to make sure to see the chat every, let's say, 5 to 10 minutes, right? That will be my idea. Now, like I said, suffix is something that starts at the very right end and always had the end at the right end. So we can say C is a suffix, and BC is also a suffix, ABC is also a suffix, DABC is also a suffix. Now ADABC is also a suffix, and CADABC is also a suffix. Like similarly, we can move on, right? Now, the overall idea is, right, if you will look here, so the idea here was to basically have a substring, right? When I say um, longest proper prefix suffix, the idea here is that you have a prefix for a particular string that is also a suffix, right? So what you can see here is that for this particular string, I have a prefix ABC, right? I have a prefix ABC, and the suffix for this string is ABC as well, right? So that is what the overall idea is, right? Now, if I want to just draw or explain this term mathematically, right? So what I will say is, now I have to have a prefix which is also a suffix, right? And if I have to find the longest prefix suffix as well, right? I have to form the prefix sum here, or I have to form the longest proper prefix, right? Now, when I say longest proper prefix, that means in this prefix array, what I will simply store here is, right, the max of 0 to I k. What is this value k? S sorry, now which is equal to I'm sorry, now that is equal to k, that is actually equal to right. Now I'll just explain this term if it doesn't make sense mathematically, right? What the overall idea is, let's say I have a string that is A B C D, right? Now what I have to do is, for each substring, I have to see which is the longest prefix suffix, right? Now, let's say this is that pi array which we were building, right? So now, considering this is the length of the string, right, there is no prefix here, so this value is always 0 for the first element, right? Now, for this much string, do you think there is any prefix of the string which is equal to the suffix? No, right? For this string, there is no prefix which is actually equal to the suffix as well, right? Now, this will be 0. Now, for this string C, what we will see here is that there is no prefix which is equal to the suffix. So, this is again 0. Now, for this string, you have to find the longest prefix suffix, right? That means the longest length of the prefix, that is also a suffix. So you will see here that for this string, the a is the prefix which is also the suffix, right? Okay, moving on, what you will see here is that for this string, the AB is the prefix which is also suffix. So for this index, I will store a 2, right? Now for this, I can see that this string ABC is a suffix which is also the prefix. So the value will be 3, right? Now for this, you can see that for this particular whole string, right, for the whole string that we have here, there is no prefix which is equal to the suffix as well in this whole string. So the answer is 0, right? I'll show you one more string. I'll show you what will be the prefix function or the pi value for this particular array, right? Let's say the string is AA B, and B, right? For now, ignore the fact that how we are going to calculate this array, right? Just understand the idea that how this array works, right? Or how is this array built? Or what exactly will be the resultant values, right? Okay. Now, for the first value, pi of 0 will always be 0, all right? Okay, now this is 0. Now for this, it is going to be 1. For this is going to be 0. And this is going to be 1, right? And this is going to be 2, right? Please feel free to ask any doubts at any point. Now for this particular string here, it will be 3 or 2. I think it should be 2. This should be 2 here because this matches with this part, right? And for B, this will be simply, what I can say here is that it should be 3 because this matches this part, right? That is what the overall idea is. Let's see for one or two more, right? Let's see it for a one or two more values, right? That will give us a better idea, I feel, right? Okay, let's say the string, just to clarify so that none of us has any doubt. So let's say it is AAB and CAD, right? If that is what is the case, what I can simply say is 0, 1, 0, 0, 1, 0, 1, 2, 3, and 0, right? So this is how you will calculate the prefix function for this particular string, right? Make sure you understand that part. Right, now let's quickly see how we can do some optimizations. Right, first we will see the optimizations, then we will see the work of pi here and how effectively pi works. Right, now let's say the text. Now we have to do some optimizations. We have to save a few iterations here. So what we will do is we'll go to ABC, we'll go to X, we'll go to A B C D, A B X, A B C, D A B. Let me take a longer one. D A B C D A B C Y. Right? Let's say this is the string that we have with us. All right. Now, how does that work is, let's say the pattern here is I think A B C D, then we have A B C Y, right? So that is what the whole, I think, the string is. Right, now we'll see, we'll make a few observations here and then we'll move forward with that concept. Right, now what you will see here is, first we will match this A and A. Let me choose another pen. First, we'll match an A and A, right? Then we match a B or B. Then we'll match a C or C. So they match. So they have been matching so far. Now, when you match a D or C, when you match this X and you match it with the D, you see that they do not match, correct? They do not match at this particular point of time, right? So now what exactly will happen is, this is the string, right? This is the string ABC that was before that. Right, now this string does not has any prefix, right? It does not have any prefix which is equal to the suffix as well, right? That is not true for any case. Right, that is the case that for the characters which matched, there was no string which is equal, no prefix that is equal to the suffix as well. So what you will do is, you follow the simple idea here, that now what you will do is, since it had no prefix, same, you will match this and A, right? uh, so what will happen here is, you will see that the X and A do not match, right? So आप ये देख रहे हो, if the prefix and the suffix do not match, right? If I have no longest prefix suffix, so you exact match from the start and you do not move backward, right? अगर आपका एक pointer X यहाँ पे आ गया है, so you're not going to move back, correct? That will be one idea here. Now what you will see here, this X and A itself do not match, so you simply increase your pointer here. So your I can say for the next idea, A is going to be here and this A is going to be here, right? If there's any point at any time, right, let me just complete this part and then you can come back to this again if any doubts. This is a long string, that means there will be a lot of iterations. Now for this A and A, they match. This B and B, they match. Okay, let me not just color it so that we don't miss out the meaning. So we have A and A, they match. We have B and B, they match. We have C and C, they match. D and match. A match. B match. Um, Now the X and this C does not match, right? Now what we see here is that this X and C does not match, right? So now what you see here is this string, है ना? You have A, B, C, D, A, B present. Right, now the overall idea is, if you will see in this string, it has a prefix which is equal to the suffix. Correct? This string has a prefix which is equal to the suffix as well, and that is of length 2. Right, now the overall idea is, agar itna part match ho raha tha, so that part must have been present here as well, right? That part must have been present here as well. And since there was a prefix which was equal to the suffix, so the idea is that aap starting se start mat karo, right? Don't start matching from this particular index because आपने पहले यहाँ से start किया था. If you know कि ये character equal है यहाँ पे, so ये वाला character तो match कर ही जाएगा ना यहाँ पे, right? This will immediately be matching here. So you don't have to start from the very start, right? You don't exactly have to start from the very start. What you can do instead here is, अगर प्रीफिक्स सफिक्स सेम था तो व्हेन यू स्टार्ट फ्रॉम हियर, राइट, ये वाला पार्ट तो मैच कर ही रहा होगा यहाँ पे. सो इंस्टेड ऑफ दैट यू स्टार्ट मैचिंग दिस एक्स विद सी. राइट, देख रहे हो आपको यहाँ पे, यू डोंट हैव टू स्टार्ट फ्रॉम द वेरी स्टार्ट. यू कैन सी दैट देयर इज सम पार्ट ऑफ द prefix which is already some suffix which is already present as a prefix, right? So what you can do is, instead you can start comparing this x with c, assuming that this part is already matched, right? Now what happens is, you will see that this for x, it does not matches with the c, right? Now like I said, आपने कुछ iteration save करी, you don't have to match from the very start, and you will see that this x does not match with the c. Now what you will see again is कि यहाँ पे एक prefix present था. Now this prefix suffix, now this string ab which was already matched, do not have anything in common, right? They don't have a prefix which is equal to the suffix as well. So your pointer comes back to the start position again, right? And now you will simply move forward from here, and you will have to match from this character, right? So आगे जो आप matching करोगे, you have to start from the very start. Now you will match this and this again. You will match this and this again, right? Now you will match this, it will match. A again match, B again match. Now make sure you see this case very carefully because it will draw a pattern here. Now you will see that this matches, right? And now you will see that this does not match. So this character essentially does not match the last character, right? Now the idea is, jo pehli string thi which matched, it was A, B, C, D, A, B, C, correct? And in this string, there was a prefix which was equal to the suffix as well. So that suffix must be present here also. So what you can do is, instead of going from the very start, what you will do in the next iteration is, you will assume that these three characters are already matched, right? Because it has a prefix suffix common, and then starts matching this D from this character, right? So now you will match D and D, they match. You will match A and A, they match. You will match B and B, they match. You will match C and they match, and you will match Y and Y, they match, right? First, tell me if you understand the very idea how the longest prefix suffix is saving our iterations. If you want, I can do a dry run once again as well, but the overall idea will be that if a particular string matched and it has a prefix which was also equal to the suffix, so for the next character that did not match, for this particular pattern, you can start just after this part, because this particular part that was at the end, it is present at the start as well, है ना? With the pattern which was present at the end, it was present at the start as well. So if these are three characters, these three characters is matched, so you can simply start matching this x with I, because ये वाला part तो match हो ही जाएगा. So why start and why compare these three characters again and again, right? If they already know that they will be matched, right? So that is what the overall idea is, and that is how the prefix functions help to our rescue, right? Now once we understand कि यहाँ पे होगा, the idea is, when we were here, right, let's say we were here, correct? We matched all these characters, right? And this character did not matched, right? This character actually did not matched. So the overall idea is whatever value is present at this index in the pi function we make, that is the index that you had to switch to, right? Now what we had done was हमने क्या किया था, right? Instead of knowing and going back to see कि कौन सा prefix match कर रहा है, हमने already we have done some pre processing here, right? We have done some pre-processing here, and based on that pre-processing, we will do the pre-processing of the pattern, right? And based on that, we know which index to shift to at this particular point of time, right? Now what we will do is we'll take the very idea only, and we'll solve the question with that very idea, right? Chalo. uh, अगेन आपको टेक्स्ट दिया हुआ है, दैट इज ABX ABCA BCABY. Let's take a smaller one this time, and we also have a pattern. Now the pattern is ABC AB and Y. Correct? So now what exactly happens is, first you will calculate the pi array or the pi function or the array, whatever you want to call it, for the pattern, right? Now how do we do that? We have A, we have B, C, A, B and Y, right? Like I told you, again, for now, just forget the fact how optimizedly or how in an optimized manner you can calculate this pi function. Just for now, for the regular purpose, just see how this works. So A, like I said, always the pi of 0 will be 0. So this is 0, this is 0 again, 0, 1, 2 and 0. So that will be the value, and these are the indexes 0, 1, 2, 3, 4, 5, right? Now, once you have done this, let me put it here only. So we have 0, 0, 0, 1, 2, and 0 again. And the indexes are 0, 1, 2, 3, 4, and 5. Right. अब हम करते हैं pattern matching once we have this prefix function. That will basically tell us how back we want to move in order to do the calculation again. Now, we will match, let me take another pen. We will match this A, it will match with A, it will match with B, we will match with B. Now this X does not matches with C, right? So now for the previous string, right, technically your I pointer is here and your J pointer is here, right, at C. Now for the J minus 1 index, right, you will check the value in the pi, right? Since it does not has a longish prefix suffix, you directly come to the start, right? So what will happen is your J pointer will essentially come here, because for the pi of J minus 1, the value was 0. That means for this particular string, this much so far, there is no common prefix suffix, right? Okay. Now J pointer is here and I pointer is at X, right? So now you will match X and A, right? So X and A do not matches. So what you simply do is, now since you are already at the 0th index, you cannot move back. Like आप और पीछे move तो कर ही नहीं सकते हो. So what you do is simply just I moves forward. So currently I is present here and we have J that is present here, right? Now you match this, they matches. You match this, they match. You match this, they match. You match this, they also match. You match this, they also match. Now when you will match C and you will match Y, you will see that they do not match, right? Currently I and Y, they do not match. Text of I does not matches with I can say it does not matches with the pattern of J, right? They do not match. So what you simply do is you go to the J minus 1, right? You check the value present at that index, that is 2. That means your J pointer will now jump to 2. So your j pointer will essentially come here, right? It basically signifies that the jth part till this part, it was all common, right? So now when you will do the matching again, right, you will match this and this value. And how did we get this value too, right? How did we know till what prefix was it common, right? Till what prefix was it common? You simply went to the j minus 1 index, you calculated the pi value, and you simply went to that index in the pattern. Correct? That is what the overall thing is. And now you will match c and this c, they match. You will match this, they match. You will match this, they match. You will match this, they match, right? And now we can simply say here that the occurrence of the pattern is simply found at this index, right? And what is that index? Basically the current index of I minus a pattern dot length, right? We can simply say that the occurrence was found at this particular point, right? Otherwise we would have to had from start here and start matching, but you can see here that how we did not have to start from the very start, and we could reduce the number of comparisons, right? So if you can see here that this I pointer definitely went to the end, right? This I pointer definitely went to the very end, right? And this J pointer also, although it did come back, but it also went to the entire length. So we can simply say that the total complexity of this algorithm is M plus N, right? M, let's say, is going to be the length of text, and N is going to be the length of pattern, right? So that is what the overall idea is. Just to tell you a quick pseudocode here as well, right? Although we will implement it, but just to show you a quick pseudocode of how this whole algorithm will work is, right? Let's say we have to do the KMP matching, right? Uh, let's say we have to do the KMP matching here, right? I have the text and I also have the pattern, right? So let's say I also have the LPS array, correct? Now, once I have the LPS array, I will have the two pointer I and j, right? Both of them are currently at the start, and we will iterate till I is less than, let's say, text dot length. I is iterating over the text, and I can simply say j is less than pattern dot length, right? So that is what the overall idea is. Now what we can simply say is, if let's say text of I, right, it is equal to pattern dot j, right? एक तो ये case हो गया that the text is equal to the pattern, right? So if that is the case, I will simply do I plus plus and I will do j plus plus as well, right? In the else case, what can happen is, if j is not equal to 0, right? Now what we saw here was, there was a time when j was already at 0 and still we wanted to push it backwards, right? But that is not possible. In other case, let's say j was at this index and then we moved it here. So there are two cases that if the pattern did not match, there are two cases. J might not be at 0 and j would be at 0 already. Correct? So if j is not at 0, that means it can be moved back. And where it should be moved back? Let's say in the LPS array, the index will be j minus 1. Right? For the j minus 1 value, whatever value is present in this array, you move j to that point. Otherwise, if j cannot be moved, you simply do I plus plus. Right? Now, when matching, right, if at any point you are matching and if j is equal to pattern dot length, right, that means simply you found the pattern, you return a true, right? And in the else case, you return false. If at any time you reach to the pattern dot length, right, here what we saw was, in the last case, when we were doing the comparison, I pointer reached here and j pointer reached here, like the naive pattern matching as well. So in the case of naive pattern matching, if you are able to reach, like in the similar case, reach the pattern dot length, that means you have found the pattern. Otherwise you have not found the pattern. So what you just should essentially do is you should return a false, right? You can see how simple and how effective the KMP algorithm is, right? Such an easy way to solve this problem, just that you need to have that LPS array, right? And that is what I was actually talking about as well, how the LPS array is the backbone of the whole idea, right? Because we have this LPS array in picture, we don't have to move back to the exact start position, right? We can save on a few iterations here and don't necessarily move to the very start, right? So building on that idea only, we say these prefixes functions are very very important, right? You can actually apply any prefix function you want, but ideally this is the way you should go about it as well, right? Just take a look here, right? I will give 2 minutes here. Just take a look if the overall idea for KMP makes sense, right? We are still assuming that we already know how to calculate the LPS array, that too in a very optimized manner, right? Because if somehow we are not able to come up with this LPS array in a very optimized way, then definitely we are in a bit of a pickle and we'll have to look for a more optimized way here. I'll give a quick break here for like a 2 minutes, right? For you to see, and if you want, you can write it down as well. The whole algorithm, right? For the KMP majorly part, then we'll talk about how do we compute this longest prefix array, right? We'll talk about that algorithm as well. We'll start in 2 minutes and we'll talk about that part. Feel free to ask any clarifying doubts about the content that we just discovered. Just giving a minute or so here. Let me know if you need more time. Otherwise, we will move forward. Yes, sure. Uh, is this what you're talking about? Yes, okay, perfect. All right, let's move ahead. Right. Like I said, in the overall approach that we discussed, right, the idea here was to have a prefix function, and that prefix function was nothing the longest prefix suffix that help us actually solve the problem in a more optimized manner. Right, now first we'll take a look that for a given string, right, for a given string s, how do we calculate the prefix function for that particular string. Right, the question here is how to calculate the prefix function for a given string of length s. Right, so one of the most trivial approaches that I can think of is right, that you can simply have all the substrings. Right, you can simply have all the substrings, and you can check for what all substrings there is a prefix which is also a match of the suffix. Right, so just to write the pseudocode here, let's say I have to calculate the LPS array. Right, so what I can simply do here is I can do, let's say, a vector, and let's say I return that vector, that is the pi array only, and let's say this is the LPS, and I pass it a string s. So I'm just writing a pseudocode here. What you can simply do is you can have a length n which is equal to s dot length. All right, and now here let's say this is of type integer, and what you can do here is you can have, let's say, the pi array that you can make again of length n. Now you can first see all the substrings. For all the substrings, this will be the kind of approach here. Now if sub dot substring, right, from 0 to k is equal to the substring from I minus k plus 1 comma k. Right, if this is equal to this, that means k is the end of a substring. Correct, k is the end of a particular substring, so I'm basically matching these parts, I minus k plus 1, and this is equal. So at the pi array at this index I simply put a k. Right, and in the end you can simply return the pi array. Now, this is the brute force approach, or the most trivial way to actually calculate the LPS array. And what we can see here is this approach easily takes up an n cubes approach, because I have n square for this, and I have another order of n for this substring function. Right, so in order to find a substring for a given string, you have a complexity of order of n. Right, so this algorithm in all takes a complexity of order of n cube. Now this is not a very optimized way to do this. Right, what we will do is we'll look for a better approach here to solve our problem. Right, okay, and how exactly do we do that? Right, based on a very important observation here. Right, and we will like see a few examples here as well. um, Let me draw another one so that we get a better idea of how things are working. Right, let's draw the prefix, I would say, functions for a few strings. Let's say the string s is a b c d a b e, and ABF. So for this, we know that the LPS array looks something like this, right? And let's say for this string, the LPS array looks A, B, C, D, E, A, B, F, A, B, C. So now for this, it looks like 0, 0, 0, 0, 0, 1, 2, 0, 1, 2, 3, right? So now the common observation that should be made at this particular time, and one of the most important observations that should be made here is that you will see the values of the prefix functions or the LPS function that we have. It always and it can only increase by at most one. करेक्ट? अगर आप यहाँ पे थे, राइट, अगर आप यहाँ पे थे और आपने ये अगर स्ट्रिंग मैच करी है, राइट, एंड अगर इसकी वैल्यू इट कम्स आउट टू बी 1 हियर, राइट, नाउ फॉर दिस स्ट्रिंग द वैल्यू कैन ओनली बी 1 plus 1. Either it will be 1 plus 0 or it will be 1 plus 1, right? There are only two possibilities here, correct? Similarly, if you will see for the rest of the string as well now, right, what you will see here is that for this particular string here the value was 2 because this part matched. Now the next part or the value can only increase by either 2 plus 1 or it can be 2 plus 0, right? There are no other ways that you can do this, and always this see if this matches, so you are simply able to increase it, right? So the one of the optimization, right, I would say like Knut, Morris, and Pratt, right? These were three people, right? They came up with this very idea only for this optimization, right? And how did they come up with the overall idea was using this very same observation that the value can only in the prefix function increase by a value of 1. Right now, using that very idea, we'll build our, I can say, the whole iteration here. Let me take up a string here. Let me take up a pattern here, and we'll try to now build that concept for that very string. So let's say the pattern is A, C, A, C, A, B, A, C, A, C, A, B, A, C, A, C, A, C, right? Let's say we also mention the indexes here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, right? Let's say I also take the, like, I also build a pi array for this, right? I'm not going to make an array because then it will get a little bit confusing. I'll just mention the indexes here. So for the corresponding values, we'll know what the value here is, right? Now, like I always say that for the pi of 0, the value will always be 0, right? It does not changes at all. So what you can simply do here is that for this, we know that the value is 0 only. Now, there will be a pointer I. It will iterate over the whole string, right? And it will calculate the pi value for each and every character that we come across. So technically, I have to start this I from here. There will be another pointer j that I will be using, right? And its purpose will be clear soon as well. Let me take a different color here. Let's say I is here because value for 0 is already known. And we can simply say that, let's say j is here, right? Now what we will do is we'll try to match both these characters, correct? Because आपको क्या करना है, let's say अगर एक string है ऐसे, right? तो आपको तो first और last character फिर match करना है, and then you want to move forward, Correct. So what we will do is we will match this both I would say strings, right? Now since they do not match, right? Since they do not match here, and this value j is already at 0 and it cannot go back any further, what we will simply do this, that for this index also we will store a 0, right? And now we simply move forward after that, right? Now this I pointer increments, right? Now what you will see here is this I and j, they do match here, correct? Now since they do match, that means they have a particular prefix and a suffix common here, right? Now what we do is, right, since they do match, what I am going to simply put here is I am going to put the value, um, what value do I put here is simply the index. If it is 0, I will put 1, right? So what I am essentially putting here is that in the LPS array, if there is a match, right? For if a match occur between the pattern for this particular index, I am going to put index plus 1, right? I'm going to put index plus 1. That is 0 plus 1 value is 1. And also I increment both the pointers. So now this comes here and this comes here. करेक्ट दैट मीन्स ये वाला पैटर्न तो मैच हो गया था नाउ वी विल मैच इवन फर्दर राइट बिकॉज अब ये इतनी स्ट्रिंग थी तो ये मैच कर गया था नाउ द स्ट्रिंग इज दिस एंड वी विल हैव टू मैच अगेन करेक्ट Okay. Now what will happen here is, right? Now what will happen here is we see that again this C and this C matches, right? So now for this string, whatever the value will be, that is like I said, agar match hota hai, the value will be whatever at this index is index plus 1, right? Or here I can say J. Um, it will be j plus 1 here, right? Now this will be j plus 1. So agar yahan pe 1 tha, the value will be 2. That means 2 characters have been matched in this string so far, correct? Because देखो अगर मैंने क्या बोला था कि always value will increase by 1. So when you were at ACA, right, and both these characters match, तो अगर मैं इसके आगे कुछ और add करूंगी, right, if I will add one more value here, right, either that value will increase, right, either that value will increase or that value will go back to 0, correct? यहाँ पे दो options है, या तो वो value increase कर जाएगी, right, either that value will increase. यहाँ पे अगर let's say एक और match आ गया, let's say C का match आ गया, तो क्या होगा, यहाँ पे अगर 1 था तो यहाँ पे 2 आ जाएगा, right? Otherwise let's say अगर यहाँ पे D आ जाता, करेक्ट, इफ व्हाट वुड हैव हैपेंड वाज कि यहाँ पे अगर डी आ जाता, so what will happen is जो पर्टिकुलर स्ट्रिंग थी, राइट, द स्ट्रिंग विच वाज एक्चुअली प्रेजेंट बिफोर एडिंग दिस पर्टिकुलर कैरेक्टर डी, राइट, व्हाट आई विल बेसिकली डू इज, जो ये पॉइंटर था ना, which pointer was initially I can say जो मैच कर गया था, राइट, let me give a let me show that in a smaller example. जब आप ACA मैच कर रहे थे, right, what would have happened was कि आपका I pointer यहाँ था और आपका J pointer यहाँ था, correct, और ये मैच कर गया था यहाँ पे. अब आपने यहाँ पे एक नया कैरेक्टर ऐड किया, right, let's say आपने यहाँ पे D मैच करा होता, correct, और आपका I pointer is currently here, right? So what happens in these cases is, right, and let's say यहाँ पे भी कुछ string present था, let me take an example here. अच्छा ठीक है, चलो let's move forward. I think that example will come in itself, right? Either I'll have to bring another string again, right? Let's move forward. That particular example that I'm talking about will come again, right? So now what we will see here is that this C and C matches. So now for this string, the pattern that has matched so far is this C only, right? So you're going to put 2. Now since both of them matches, we would want to match even further. So the I pointer will come here and the J pointer will come here, right? Now what we will see is, once I have matched all these, right? Once I have matched all these, now A again matches with the A, right? Why? Because this ACA actually matches with this ACA, correct? So in this string, there is a prefix suffix match here. So what we can simply do is, we know the drill here, that if there is a match, the value here will be 2 plus 1. So it will be essentially a 3 here, right? That is what the overall idea will be till this particular index. Okay. Now let's keep moving on forward again. So I is here, and where were we? We were at 3. So J comes here, right? Now J is at this particular index. Now what happens is, देखिए ये वाला case आ रहा है यहाँ पे, you see when this does not matches, correct? This is the case I was talking about, कि आपका कुछ पार्ट यहाँ पे पीछे मैच करा था, है ना? दिस पार्ट मैच्ड विद दिस पार्ट, बट नाउ यू हैव कम अक्रॉस अ कैरेक्टर, आपने जो न्यू, अब यहाँ पे थे तो ये वाला पार्ट मैच्ड विद दिस मच पार्ट, करेक्ट, ये कॉमन कैरेक्टर था। अब जब यहाँ पे आपने न्यू कैरेक्टर ऐड करा है, राइट, वेन एवर यू एडेड अ न्यू कैरेक्टर, आपको पता चला कि इट इज नॉट मैचिंग with wherever your j pointer was, correct? So now in this case what you are simply going to do here is, आप देखोगे कि जो आप करंट इंडेक्स पे हो उसके +1 पे क्या वैल्यू पड़ी है, 1 पड़ी है, राइट? व्हाट यू विल सिंपली सी हियर इज कि आपका जो भी इंडेक्स था, राइट, अगर आप करंटली जे पे थे तो आप j-1 पे जाओगे, आप एलपीएस एरे में j-1 की वैल्यू चेक करोगे, सो फॉर j-1 it was a 1 and your j pointer will move here. So essentially what, okay, just give me a second. Essentially what will happen is, your I pointer will remain here but your j pointer will go here, right? And how does that happen? जो भी आपका current j pointer था, आप j-1 index पे करे, उस पे जो भी value present थी, you moved there, right? And why did you moved here? देखो, because यहाँ पे आपको पता है कि for this part this much part is matching, correct? Now for this string, so जो ये आपकी current string है, करेक्ट, आपने देखा जो पिछली स्ट्रिंग थी, राइट, A, राइट, फॉर दैट स्ट्रिंग व्हाट यू हैड इन कॉमन, राइट, एंड दैट पर्टिकुलर पार्ट वाज AC, करेक्ट, एंड दैट पर्टिकुलर पार्ट वाज जस्ट A, करेक्ट? जो आपकी अभी आप करंटली यहाँ पे हो, आपने देखा कि ये जो पूरी स्ट्रिंग है उसमें लास्ट तो मैच नहीं कर रहा है, बट फॉर द रेस्ट ऑफ द स्ट्रिंग, राइट, बट फॉर द रेस्ट ऑफ द स्ट्रिंग दैट वाज देयर, यू सॉ विच पार्ट वाज मैचिंग, दैट वाज ए, राइट? तो आपने क्या करा, सी पार्ट से यहाँ पे स्टार्ट कर दिया मैच करना, करेक्ट? आई होप दैट मेक सेंस, अदरवाइज इट विल लाइक कम in the future stages also, so you will like get a better idea of how the iteration will work, right? I have drawn a big string for this purpose only. Now what you will see here is कि यहाँ पे भी this C and this B does not match, है ना? जब आप J pointer को यहाँ पे ले आए using the same part, you saw that it do not match, तो आप same चीज करोगे, आप j-1 point पे जाओगे, right? आप उस पे value check करोगे and you will simply move there. So यहाँ पे आपने देखा this value was 0, this value was 0, so you simply move to this index, correct? Now when you move to this index, you saw that A and B again do not match, right? This A and this B again do not match, but since you cannot move the J pointer any further, right, since you cannot move the J pointer any further, so for this B you will simply put a 0 here, right? You, for this B you will simply move a 0. Let's take a few more iterations here, put a few more cases here so that it helps. Now you are at A, right, and you are going to match it with this part. Now this and this match, right, this and this match, right? So what you're going to put here is, you're simply going to put a 1, right? I always said कि जो भी J पे present होता है, if there is a match, तो आप J+1 की value उस index पे डाल देते हो. Okay, now what will happen is, your I will come here and your J will come here. Now since I and J match, so you simply move forward. I will come here and J will come here. They again match, so I will come here and J is actually here, right? Now you again match, I comes here and J comes here. Now they again match, So I comes here and J comes here. So they again match. Now I comes here at this A and J is here, right, at this particular A. So they again match. Um, Let me just reduce the previous pointers which were already matching, right? Now what will happen is your J pointer will come here, right, and your I pointer will come here. Now they again match. Now this I pointer will come here and this J pointer also comes here, right, and they keep on matching, right? So far we have been finding a match, and like I said, if you find a match you had to update the value. So the here the values were getting updated similarly. So we simply had 2, 3, 4, 5, 6, right, because all these characters keep on matching. We had a 7, we had a 8 here, right? Now this A and this A also matched, so we have a 9 here as well, right? Now this C matched with this, I think, particular character C, so we again had a match, है ना? So these 10 characters have been matching here. I will show you quickly where we are at this point. Um, so currently what we can say here is that currently my J pointer is here, and what we can see here is that my I pointer is here. I'll reduce or remove all the other pointers, right? अभी मुझे सारे matches ही मिल रहे हैं. So currently my J pointer is here and my I pointer has actually reached here because I found all the matches, correct? Now what will happen is also the value here, since they were a match, so यहाँ पे अगर 10 था, right, and this A and A match, so like I said the value here will update to 11, correct? Now see the last case here very carefully. Now you will come to J here, right, and you will come to I here, correct? Now what happens is ये वाले characters do not match, correct? All had been matching so far, but ये वाले characters did not match. और essentially match क्या part हुआ है? This much part. This I can say the part from here to here, A, C, A, C, A, B, A, C, A, C, A, right? So this much part was matching, right? With what part? This much part. Correct, because जो ये वाला part था, right, for this much string, right, ये अगर पूरी string है till 0 to 16th, तो इसमें ये वाला part, the yellow part, that was the prefix. If I denote the yellow with the prefix, it was matching, sorry, the yellow with the suffix, it was matching with the prefix. That was the blue part, है ना? इतना part तो match कर रहा था. Now what part was not matching, right? What part was not matching? जब मैंने एक new character add किया तो string ये हो गई, correct? The string became 0 to 17. Now this part essentially did not match, correct? This part essentially did not match here. So like I said, when a particular part does not matches, right? If I have to write it in this terms, if I can say that the pattern of, let's say, I is not equal to the pattern of J, right? If that case happens, right, and also here, the J is not at the 0 pointer, right? J wala pointer is आगे है. So like I said, what you do is आप J minus 1 pointer लेते हो, right? You see what the LPS array is for this pointer and you move your J pointer to there. And why are we doing this? अब वो ज़्यादा clarity मिलेगा, right? So अभी क्या था? J pointer was here, correct? जब आप यहाँ पे गए, that was J minus 1. इसके corresponding value was what? 4. correct. इसके corresponding the value that we had was 4 here, 4 or 5, let us check. Okay, this will be 5, right? Because यहाँ पे 10 index है. So the corresponding value here was 5, right? So what you do is you move your j pointer to 5. अब देखना, you will draw the observations here as well. When you move the j pointer to 5, you will see जो नया string बना था ना, उसका इतना part was common, right? That much part was actually like the common part, right? You will see कि यहाँ पे क्या था, ये, राइट, AC एंड ए, राइट, एंड यू विल सी यार ये यहाँ पे कॉमन था, AC एंड ए, राइट. तो आपको क्या हुआ, आपको स्टार्ट से स्टार्ट नहीं करना पड़ा. देखो, जो ये वाला पार्ट था दैट वाज एक्चुअली कॉमन एंड इट वाज प्रेजेंट हियर एज वेल, राइट. तो यू नो कि भाई इतना पार्ट तो कॉमन है. अगर ये वाला कैरेक्टर बी मैच कर जाएगा, राइट, तो यू कैन से जो प्रीफिक्स वैल्यू हो जाएगी वो 5 + 1 6 हो जाएगी, है ना. बिकॉज ये वाला पूरा पार्ट will match with this part if this b matches where you currently are, correct. So that is why you see कि हम पूरा back move नहीं करते हैं, we only back move to a certain value. So now आपका j pointer यहाँ पे आ गया और आपका i pointer यहाँ पे है. Now when you match this b and c, तो ये again match नहीं करे. That means you will look for a more shorter prefix जो कि मैच कर जाए इस सफिक्स से, राइट. तो अगेन द आइडिया विल बी कि आप j+1 वाले पॉइंटर पे जाओ एंड उसके कॉरेस्पॉन्डिंग वैल्यू चेक करो इन द एलपीएस आरए, राइट. तो मतलब इस वाली स्ट्रिंग में जो लॉन्गेस्ट प्रीफिक्स सफिक्स था दैट वाज ऑफ लेंथ 3. तो आपका पॉइंटर आ गया j यहाँ पे, correct. Now when you match this pointer value j na, you will see here that this value again does not matches with my c value, right. So again आप पीछे move करोगे, so that means आप second pointer पे आओगे, उसकी lps value check करोगे, that is 1, right. So आपने यहाँ पे c pointer पे move कर लिया, right. तो आपको ये पता है कि अभी भी ये वाला part, this a part is also a a part. तो अगर c match कर जाएगा यहाँ पे, again the length will be 2 here again, and that happens in this case कि यहाँ पे जो c था it does matches here, and you can simply say that the lps value here simply becomes I can say, अच्छा वो एक्चुअली ना यहीं पे ही मैच कर रहा था. देखो, वन मिस्टेक दैट वी डिड हियर इज, हम यहाँ पे थे, राइट, हम जे पॉइंटर पे थे, तो ये बी और ये सी तो मैच नहीं करा था, राइट. सो देन वी टॉक v4 - 1 एंड वी केम दिस वैल्यू 3, right. So when we came at j pointer here, so this c was matching with this c, correct, and the value came out to be 4 here because वो 3 + 1 होना था, right. So that means this much part is the longest prefix suffix. Is this clear to everyone? If you want, I can do one more dry run on a smaller example, right? But like this is what the overall idea will be here. If this makes sense, let me know, right? That the overall idea is clear to you and you can understand what the idea is. All right. Let's take this. Do you want me to explain for the very last element? For the very last index element? Yes, okay, perfect. Let's work on that. Let me clear it out a little bit. ठीक है. I hope for the rest of the string it was clear, right? अगर उसमें भी doubt है तो ask me again. I'll complete that part as well. Okay. I think it was C. This is A. All right. So what we saw here was, currently when we were doing this particular iteration now, right? When were matching the prefixes and the suffix here, what we saw was you were currently at this element. Your J pointer was here and your I pointer was here, right? Matlab, wherever the I pointer is pointing at, you have to find the longest prefix suffix for that particular string, right? एंड फॉर दिस, लाइक आई सेड, अब आपके पास इतनी स्ट्रिंग का आंसर है, अब आपने एक कैरेक्टर और ऐड करा है, राइट? सो यू हैव टू फाइंड दैट एंड करंटली आई इज पॉइंटिंग एट दैट पॉइंटर, राइट? एंड फॉर दिस मच पार्ट, हाउ मच पार्ट वाज मैचिंग वाज, राइट? लेट्स से फॉर द स्ट्रिंग 0 to 16 ये वाला पार्ट वाज मैचिंग. दिस वॉज द प्रीफिक्स ऑफ द, लेट्स से अगर ये x है, राइट? इफ दिस वॉज द x position, तो x minus 1 string में this much was the suffix which was matching with this much prefix, right? So currently we can say here that the j pointer always denotes, right? The j pointer always denotes the length of the लॉन्गेस्ट प्रीफिक्स सफिक्स ऑफ द x माइनस वन स्ट्रिंग, है ना? जो j होता है ना, वो हमेशा वो लेंथ डिनोट करता है ऑफ द लॉन्गेस्ट कॉमन प्रीफिक्स सफिक्स फॉर द x माइनस वन स्ट्रिंग. अगर ये x था कैरेक्टर, तो वो x माइनस वन स्ट्रिंग की लेंथ पे हमेशा डिनोट करता है, ठीक है? ओके, now so what we are simply going to do here was, if that is the case कि आप जो currently pattern I पे है, if it does not matches with the J ना, so यहाँ पे था J, right? तो आप क्या करो, जो ये वाली string थी ना, this much string, you find out what is the longest common prefix suffix for this much string. ठीक है, आप इतनी स्ट्रिंग का लॉन्गेस्ट कॉमन प्रीफिक्स सफिक्स ढूंढो. देखो, अगर यहाँ पे ये कैरेक्टर मैच हो जाता यहाँ पे, तो अब यहाँ पे वैल्यू 12 स्टोर कर देते, करेक्ट? बट अब यहाँ पे तो ये कैरेक्टर मैच कर नहीं रहा है, राइट? सो व्हाट यू विल डू इज, यू विल गो, इफ यू आर एट करंटली हियर, तो आप क्या करोगे, इस वाली स्ट्रिंग का लॉन्गेस्ट प्रीफिक्स सफिक्स देखोगे, और ये वैल्यू कहाँ प्रेजेंट होगी, इस वाले इंडेक्स पे. अगर यहाँ पे j था, तो ये वाली वैल्यू यहाँ पे प्रेजेंट होगी, बिकॉज एट अ पर्टिकुलर इंडेक्स आप क्या इंफॉर्मेशन स्टोर करते हो कि उस लेंथ तक की स्ट्रिंग का लॉन्गेस्ट प्रीफिक्स सफिक्स क्या है, राइट? तो जो इंफॉर्मेशन मेरे को चाहिए वो यहाँ पे प्रेजेंट है, करेक्ट? विच इज बेसिकली प्रेजेंट एट j माइनस वन एंड द पाई वैल्यू ऑफ दैट, राइट? सो आप क्या करोगे, आप इस वैल्यू पे जाओगे, राइट? और आपने देखा कि जो इतनी स्ट्रिंग है ना, उसका जो लॉन्गेस्ट प्रीफिक्स सफिक्स है, उसकी लेंथ है 4, विच इज दिस. करंटली, अच्छा, करंटली ना वी आर एट दिस, अगर ये लेंथ डिनोट कर रहा है, सो currently we are at this particular pointer, all right? और तो आपको क्या करना था, वही j माइनस वन पे जाओ और उसकी पाई वैल्यू देखो. तो यहाँ पे योर j माइनस वन इज दिस, दैट इज 10, राइट? एंड हियर द वैल्यू इज 5, राइट? तो आप क्या करोगे, आपको पता चला कि ये वाली जो स्ट्रिंग थी, for this much string, the longest prefix suffix was of length 5, which is this part. Correct? ये वाला part था which was equal to this part for the string of length j minus 1. Correct? तो आप क्या करोगे, आप यहां पे मूव कर जाओगे सीधा, ठीक है? You simply move at this point, that means your j pointer comes here, right? Now why this happens is कि देखो, अगर ये वाला पार्ट we know कि इस वाले पार्ट से मैच कर रहा है, ठीक है? अब अगर ये वाला कैरेक्टर इस वाले कैरेक्टर से मैच हो गया, देन मैं यहाँ पे वैल्यू सिंपली 6 डाल सकती हूँ, करेक्ट? देखो, राइट, आई कैन सिंपली पुट 6, बट व्हेन आई कंपेयर दिस b and c, they do not match, correct? So what I have to do is I even have to look for smaller values here, right? तो मैं क्या करूंगी, अगेन मैं जो इतनी स्ट्रिंग है ना, उसका लॉन्गेस्ट प्रीफिक्स सफिक्स देखूंगी, विच इज द वैल्यू j-1, राइट? इतनी स्ट्रिंग का देखना है ना, तो इसकी वैल्यू कहाँ पे है 3, तो मैं क्या करूंगी, j पॉइंटर को यहां मूव कर दूंगी। ठीक है, अब रीजन क्या है मूव करने का, मुझे पता है जो इतनी स्ट्रिंग है ना, इसका जो लॉन्गेस्ट प्रीफिक्स सफिक्स है विच इज दिस, है ना, लॉन्गेस्ट प्रीफिक्स विच इज ऑल्सो अ सफिक्स। तो अगर ये वाला कैरेक्टर मैच कर गया विद दिस कैरेक्टर, सो आई कैन सिंपली से कि वो लेंथ क्या हो जाएगी 4, राइट? बिकॉज ये तीन कैरेक्टर तो यहाँ पे भी प्रेजेंट है, राइट? तो अगर ये कैरेक्टर मैच हो गया इस कैरेक्टर से, तो लेंथ क्या हो जाएगी 4, राइट? इन अदरवाइज देखो आपको क्या करना पड़ता है, ये जे पॉइंटर वहां था ना, आपको इस पॉइंटर को स्टार्ट पे लाके करना पड़ता, फिर आप ए को मैच करते, फिर यहाँ पे सी को मैच करते, ऐसे मैच करते, राइट? बट नाउ व्हाट यू डूइंग इज आप पूरा डायरेक्टली जे को मूव नहीं कर रहे, आप धीरे धीरे मूव कर रहे हो। अब यहाँ पे जो आपने सी कैरेक्टर को यहाँ से मैच किया, वो मैच हो गया, तो मतलब कौन सा पार्ट कॉमन था, ए सी विच वॉज कॉमन विद दिस ए सी, सो ये लेंथ आ गई यहाँ पे 4। Is this now clear? All right, perfect. Chalo, let's take a dry run for this as well, right? Let's take a dry run for this as well. Then we will implement the whole part in one logic, right? तो अगर आपको LPS array compute करना है, right? मैं बहुत ही similar logic लिखूंगी यहाँ पे। आप क्या करते हो, आप पैटर्न यहाँ पे पास करोगे, करेक्ट? और आप यहाँ पे पहले तो एक नया LPS array बना लो, which is equal to पैटर्न डॉट लेंथ, और या ऐसे लिख लेते हैं, विच इज इक्वल टू न्यू int pattern dot length, right? The length is same. Now initially let's say the j pointer is at 0, right? So what you simply do is for, मैंने कहा था ना for LPS of 0 it will be 0, right? तो initially जब एक when we make an array the values are 0, so simply start with the first index, you go till the pattern dot length and you do I plus plus, right? और यहाँ पे मन नहीं करते हैं, let's say I plus plus, we'll do it moving forward, right? Okay, now what we do here is we first check if the pattern of I is equal to pattern of j, right? We first check this condition, right? If this is true, so what we used to do was whatever will be the index, what will be the value present in this array, it will be simply j plus 1, right? हम यही वैल्यू स्टोर कर देते थे अगर कैरेक्टर मैच कर जाते हैं, करेक्ट? In the else case, or what we did was then we did I plus plus and we also did j plus plus, correct? In the else case what happens is, मतलब यहाँ पे तो मैच नहीं करा है, we did not find a match. अब यहाँ पे भी दो conditions हैं, if j is not equal to 0 or if j is equal to 0. अगर j pointer already 0 पे है, so we cannot move it forward, right? Now this is the case where j is equal to 0, right? So in this case आप क्या करते हो, LPS array में ना उस position पे simply 0 डाल देते हो, because you cannot move forward and you simply do I plus plus, right? Otherwise what you do is, अगर वो value non zero है, so आप j plus 1 पे जाते हो, उसकी LPS वैल्यू देखते हो एंड यू सिंपली गो, है ना? यही हम करते थे, दिस इज हाउ वी यूज टू फिल द वैल्यूज एंड इन द एंड you simply return the LPS array. Is this part clear to everyone? How this whole algorithm works, then we'll go ahead and implement it also. Clear, right? Chalo. Now let's take it on an IDE and see if this works. And also one important thing which we were discussing here, right? What you will see here is the overall time complexity, right? The overall time complexity to calculate this LPS array is actually size of pattern, right? A great optimization over the previous, I think, n cube approach, right? A great optimization. And that is what Morris and the third person, that was Pratt, came up with, right? These are three different people who came up with this very efficient approach to calculate the LPS array, and that in fact actually helped us solve the prefix or the string matching function in a very, very optimized manner, right? Okay. एक काम करते हैं, let's take another 2 minutes break here. Feel free to see the what way I have written as a part of this function. पहले पूछ लो if you have any doubts about this, because if I'll then simply move forward, then you'll not understand the concept. So take a minute here, see if the overall ideology makes sense. If you want, you can write down the pseudo code as well, right? And then we will move forward and write the implementation for this. I'll quickly give you 2 minutes here to see, and then we will move ahead. I'll just give a minute here more. If you want to see and understand the whole concept, and try to take a minute back to see, and then we will move forward. All right. Let's quickly go ahead now and try to do the implementation for this. Okay. So this is the seventh class, I believe. All right. Let's first write those individual functions for matching here. Let's say you have to basically tell if there was a match or not. So you will be given, let's say, a character of array of text, and you are also given a character array of pattern. All right. So what happens here is you have, let's say, the LPS array, right? And let's say you call the function which computes this LPS array for the pattern, right? And it gives you this array. Let's write this array first, because we just did it, so we'll remember it more significantly. Right. So what it basically does is you have int, you have this LPS array, and first you make the new array, which is equal to pattern dot length. All right. Okay. Now we have int j is equal to 0, and we'll start with saying that, although it's obvious, but you can write it as well, that LPS of 0 is equal to 0, right? So then we'll move on to int I is equal to 1. It will go till pattern dot length. All right. Now there are two cases here. If pattern of I is equal to pattern of j, right? So that is the one case, and there is the other case. Now if this matches, so what you do is, in this LPS array, right, at this index I, you put j plus 1. Correct? Now in the else case, there are two again cases. If j is not equal to 0, or the other case is j is equal to 0. Now if j is equal to 0, that means j cannot be pushed back further. Correct? That means j cannot be pushed back further. So what you simply do here is, on this particular index you put 0, right, and you put I plus plus. You simply move the I forward. Now for this case, what you do is, first you go to j minus 1, right? You first find the LPS value at this index, right? And whatever the value is, you move your j pointer there, right? And also in this case, when there was a match, we also did j plus plus, we also did I plus plus. Correct? So this is the particular case of how you are going to compute the LPS array. In the end, you simply return this particular array, right? Okay. Now when we are done with the computing part, right, you see here I'm actually just implementing what I was speaking, right? Nothing more or less than that. Now what happens next is, you have to start with the matching, right? So now in the matching, we remember there were two indexes, right? This I will basically iterate over the text. This pattern, or this pointer, will iterate over the text, and this will iterate over the pattern, right? Now what happens next here is, till the time I is less than x dot length, and j is less than pattern dot length, right? Now again, there are two cases here. If text of I is equal to pattern dot I, pattern of I, right, pattern of j, sorry, right, that is one case. And the other case is when the current characters at I and j index do not match, right? अगर वो दोनों मैच कर रहे हैं, राइट, इफ दे बोथ मैच, तो आपको कुछ करना ही नहीं, यू सिंपली कीप ऑन मैचिंग. अगर एक कैरेक्टर मैच कर गया है, देन यू शुड कीप ऑन मूविंग फॉरवर्ड. बट अगर दे डू नॉट मैच, दैट मीन्स you have to slide back. So you don't slide back to the very start, you just slide back to that index with till which you basically have a match here. So again, अगर j is not equal to 0, तो दो केसेस हैं यहाँ पे भी. अब आप j which is sliding over the pattern, आप उसको slide कर रहे हो. In the else case, there is another case, right? So this is for the case when j is equal to 0. अब अगर j इक्वल टू 0 है, तो आप तो कुछ पीछे मूव कर ही नहीं सकते. सो आप सिंपली बस अपना इंडेक्स आगे बढ़ा दो इन द टेक्स्ट. बट इफ j इज नॉट इक्वल टू 0, तो आप क्या करते हो, आप j माइनस 1 पे जाते हो, राइट? यू सी वहां पे क्या LPS एरे में वैल्यू प्रेजेंट है, और आप उस इंडेक्स पे मूव कर जाते हो. Correct? Because that is the index, राइट, जो भी एलपीएस वैल्यू j -1 पे प्रेजेंट था, मतलब उतना पार्ट तो मैच कर ही रहा है, सो यू डोंट स्टार्ट मैचिंग फ्रॉम दैट इंडेक्स अगेन, राइट. नाउ इन द एंड इफ द j pointer is equal to pattern dot length, so you return true, right. Otherwise, in the else case, what you do is you return false, correct. Chalo, let's run this. Let's say the string str is a b c x a b c d a b c d a b c y. All right, let's say let's call it the text, and let's call it the pattern. All right, now here we have, let's say, again the same values a b c d a b c y. All right, now you have to search. So you put the KMP function, you pass the text, you pass the pattern here as well, and whatever this function returns to you, to simply print it. Now this needs to be static as well, because this is this case, and now also this, because we are calling static from static function, so all needs to be static. Okay, so what we can do is we have to pass the array, so we convert it. All right, let's see. So it says true. Why? Because this pattern is actually present here, right? So that is why it's a match. If I would have, let's say, put an L here, so they would not have match. So I've put a false here, right? If you want, like, you can reduce the string as well. Let's say I do just keep it till here. So again, I think there should be a match. Yeah, why? Because this pattern itself is present at this position, right? So that is why this is a match, right? Now, just to take a look here at the time complexity, right? You can see here that simply there is a string, and we have a pointer I which is iterating over the whole pattern. So here the time complexity to calculate this will be O of size of pattern, right? And here, since we are iterating both the pointers over the text and the pattern, here the complexity is order of text dot length plus pattern dot length, right? So in the end, if we add both the complexities, right, if we add both the complexities, what we can essentially see here is that the total time complexity here will be order of m plus n, right, where m is the size of the pattern, let's say, and n is the size of the text. All right, so that is what the overall complexity will be, and that is definitely an optimized process over a complexity of m into m, right? Greatly optimized. Not for small cases, it might not make a very big difference, right? Let's say if the length of the pattern and the text is almost same, let's say 10 and 10, right? So in that case, there is although there is still a optimization, but not a very big optimization. But yes, for very big cases, for very large length of the pattern, this is a great optimization here, right? So we looked at two both algorithms. Most of them are very optimized. In the last class, we had a look at, I think, Z algorithm. Again, a very optimized algorithm, a very good one as well, because it helps solves a lot of problem in an optimized manner. And the algorithm that we covered today is the KMP algorithm, and it works on the overall same idea only, right? So that is what the overall concept is. Does everyone had like a good understanding of what we tried to cover in this? Did you were able to learn KMP in a way that, my idea always is that these algorithms are usually something that you can forget. So always try to learn it in a way so that you don't forget it now again ever, right? In this whole course on string algorithms, we actually covered a lot of algorithms, and it's very easy to forget them. But you will see that strings is again a very important topic. It will greatly optimize your string matching parts. So just make sure you remember all these algorithms, right? I'll try to see if I can fetch up a few problems for you, right? Which you can try, right? We'll not be covering them in the class because they involve some extra concepts as well, right? They might involve a few dynamic programming concepts as well. So just feel free to try them, right? What I would again say is, for KMP algorithm, you will not statistically find questions on KMP, but for the LPS array that we constructed, you will find a lot of questions on that, right? Like I said, जो कॉन्सेप्ट है ना वो एक्चुअली प्रीफिक्स फंक्शन का कॉन्सेप्ट है, एंड यू कैन एक्चुअली से द कॉन्सेप्ट और द एप्लीकेशन ऑफ दैट प्रीफिक्स फंक्शन इज केएमपी एल्गोरिथम, राइट? नॉट द अदर वे अराउंड, राइट? तो जो मेन कॉन्सेप्ट है दैट इज ऑफ द प्रीफिक्स फंक्शन एंड द लॉन्गेस्ट common prefix suffix concept, that is the concept, and one of its application is string matching, right? And we call that string matching part as the KMP algorithm, right? So I want you to relate these things in that part, right? I'm sharing a link for a few problems for code forces, right? Which you can try. They are like div 2 problems, so they'll not be very easy, but you should be able to get a hint of things. So they are div 2 problems, so they're not going to be very easy, but like I would want you to like give a try and see if that works for you, right? If you have any doubts, feel free to clarify, feel free to ask. Otherwise, I think we're going to end the class today. I hope everyone had fun learning string algorithms. We had one more class on this course, which is going to be on Aho-Coracic, in which we are going to cover up the rest of the concept, right? And then this will be end of the course. We'll try to come up with another string algorithms 2 course, in which we'll cover some more advanced concepts, but we'll see where it leads us, all right? Okay. Thank you everyone for attending, and I will definitely meet you in the next class on next Sunday. So please try to attend all these classes, right? Thank you. Bye bye. Good night.